Hi kids, I am Teacher Art and I am a math teacher. Today we are going to learn about techniques in finding the LCM or the least common multiple of two or more numbers. We are going also to use division method or the L method in finding the LCM or the least common multiple of two or more numbers. What is a least common multiple or LCM? It is the greatest whole number which is divisible by all the given whole numbers. Let's find the least common multiple or LCM of 6 and 8. The greatest whole number which is divisible by both 6 and 8 is 24. So the LCM of 6 and 8 is 24. Take note that when we say the number is divisible by the other number, when you divide them, there is no remainder. The LCM of two numbers 6 and 8 cannot be 1, 2, 3, and 4 because they are less than 6 and 8. And obviously, 1, 2, 3, and 4 are not divisible by 6 and 8. The LCM of 6 and 8 cannot be 6 because 6 is only divisible by itself. And the LCM cannot be 8 because 8 is only divisible by itself. The LCM cannot be 12 because 12 is only divisible by 6. The LCM cannot be 16 because 16 is only divisible by 8. And the LCM cannot be 18 because 18 is only divisible by 6. Least common multiple or LCM is used in addition and subtraction of dissimilar fractions. When we say dissimilar fractions, the bottom numbers are different. 4 and 5 are the bottom numbers or the denominators. 3 and 2 are called numerators. Let's find the LCM of 4 and 5. What do you think is the LCM of 4 and 5? Yes, you are right. It's 20. And 3/4 will become 15 over 20. How could that be? That happened because I got the equivalent fraction of 3/4. Therefore, we can say that 3/4 is equivalent to 15 over 20. How? Multiply 4 by 5 to get 20. And because we multiply 4 by 5 to get 20, we will also multiply 3 by 5 to get 15. 2/5 will become 8 over 20. What number are we going to multiply to 5 to get 20? 4. If 4 times 5 is 20, 4 times 2 is 8. Now, take note of the rule in addition of similar fractions. Similar fractions have the same denominators or the numbers at the bottom part are just the same. So 20 is now called not the LCM. It is now called least common denominator because it is the new denominator. Okay, it is the denominator of 15 over 20 and 8 over 20. 15 over 20 and 8 over 20, once again, are called similar fractions. And the rule is just add the numerators and copy the common denominator in adding these fractions. 15 plus 8 is 23 and copy 20. In lower grades, we change an improper fraction to a mixed number such that the fractional part is in lowest terms or simplest form. 23 divided by 20 is 1. And the remainder is 3 over the denominator or the least common denominator or the LCD, which is 20. Again, it's 1, remainder 3. You put the remainder on top and the LCD at the bottom. And 1 is called the quotient. So 1 and 3 over 20 is the answer when we add 3/4 plus 2/5. Again, the LCM here is 20. It's the LCM of 4 and 5. And 20 is the LCM of 3/4 and 2/5. Or the LCD. Again, 20 is the LCD of 3/4 and 2/5. LCD, least common denominator. I will give you some tips or hints in finding the LCM of the given whole numbers. Tip number 1. If there are two numbers and the other number is divisible by the smaller one, then that greater number is the LCM of the given whole numbers. For example, 48 and 96. 96 is the LCM of 48 and 96. Take note, 96 is divisible by 48. Tip number 2. The LCM of two given whole numbers is not less than any of the given whole numbers. Example, the LCM of 3 and 4 cannot be 2 or 1. 1 and 2 are obviously less than 3 and 4. And when we use multiples of 3 and 4, we can get the LCM, which is 12. By the way, please remember your lesson in finding the LCM using the listing method, or also known as listing the multiples method of 3 and 4. And let's go to tip number 3. The LCM of two given whole numbers is greater than or equal to the bigger whole number. The LCM of 12 and 6 is 12. 12 is equal to the greater number. And that's it. And now, we are going to use the division method or L method to find the least common multiple of two or more numbers. Let's start. Let's get the LCM of 12, 16, 20, and 24. Step number 1. Write 12, 16, 20, and 24. And that one is the division sign. Take note that we will use prime numbers as divisors. What's a divisor, by the way? Example, 12 divided by 2 is 6. 2 is the divisor. 12 is the dividend and 6 is the quotient. Again, 12 divided by 2, 6. 2 is the divisor. So later, we are going to know what number is divisible into 12, 16, 20, and 24. Specifically, what prime number is it? Can we divide all of them, 12, 16, 20, and 24, by a prime number 2? How about 3? How about if not all of them are divisible by any prime number in the box? What are you going to do? Of course, you can search the internet for other prime numbers greater than 97. Now, what is a prime number again? A prime number is a number that has only two factors. Example of factors: 2 is equal to 2 times 1. 2 and 1 are only the factors of 2. There are only two factors. 3, the factors are 3 and 1, or 1 and itself. 3 times 1 only. So 3 is a prime number. 5, the factors of 5 are only 5 and 1. So 5 is a prime number. Again, these are the first 25 prime numbers only. You can search the internet for the other prime numbers which are greater than 97. Let's start. Choose a prime number from the box which is divisible into 12, 16, 20, and 24. What is it? Yes, correct. 2. All of them are divisible by 2. How about if not all of them are divisible by 2? Let's find out later what will happen. But this time, I can assure you that 12, 16, 20, and 24, all of them are divisible by 2. 12 divided by 2 is 6. 16 divided by 2 is 8. 20 divided by 2 is 10. 24 divided by 2 is 12. Because this is division method, we are going to divide 6, 8, 10, and 12 again by a prime number. Could it be 2, 3, 5, or greater than any of them? But let's check if all of them, if 6, 8, 10, and 12 are divisible by a prime number. 6, is it divisible by 2? How about 8? How about 10? How about 12? Yeah, they are all divisible by 2. So we will divide them by 2. 6 divided by 2 is 3. 8 divided by 2 is what? 4. And 10 divided by 2 is what? 5. How about 12 divided by 2? 6. Now, let's check if 3, 4, 5, and 6, all of them are divisible by any prime number. I have found out that 3 is not divisible by 2. Okay, now, what are we going to do? Let's check the other numbers. How about 4? 4 is divisible by 2. Yes, it's divisible by 2. 5 is? Yeah, 5 is not divisible by 2. 6 is divisible by 2. In that case, we can divide 4 and 6 by 2. What will happen to 3 and 5? Because 3 and 5 are not divisible by a prime number, 2. Just copy them. Copy 3. 4 divided by 2 is 2. Copy 5. 6 divided by 2 is 3. Let's check once again. 3, 2, 5, and 3. Not all of them are divisible by any prime number. Let's check. 3 and 2, 3 and 5, 3 and 3. It's 3 and 3. 3 and 3 obviously are divisible by 3 itself. So, let's divide 3 by itself. The answer is 1. Since 2 and 5 are not divisible by 3, just copy 2 and 5. And once again, 3 divided by itself is equal to 1. Let's check 1, 2, 5, and 1 once again. Are all of them divisible by any prime number? 1 and 2, 1 and 5. No more. They are only divisible by 1. But 1 is not a prime number. In this case, we have to stop dividing. Oh, there is a letter L. The red color indicates letter L. What are we going to do with the numbers at the side of L and the numbers 5, 1, and 2 at the bottom part? We are going to multiply them. Since multiplying by 1 is just the same number, we will skip that. We will just multiply 2 times 2 times 2 times 3 times 2 times 5. Okay? Even if we will skip 1, it doesn't matter. Any number multiplied to 1 is still the same number. And if you want some multiplication techniques, 5 times 2 is 10, 10 times 3 is 30, times 2, 60, times 2, 120, times 2, 240. And 240 is the LCM or least common multiple of 12, 16, 20, and 24. Let's go to example number 2. Let's find the least common multiple or LCM of 24, 36, and 48 using division or L method. First step, write them down first and the division symbol. Again, in this case, we use two perpendicular lines to represent division symbol. And step number 3, write down the prime numbers that we can use. And once again, if they cannot be used as divisors, you can have a prime number which is greater than 97. Search the internet. All right? Now, let's check. 24, 36, and 48. Are all of them divisible by any prime number? Yes. Can we use 2? Yes. And 24 divided by 2 is 12. 36 divided by 2 is 18. 48 divided by 2 is 24. Let's check 12, 18, and 24. Are all of them divisible by any prime number again? Yes. What is it? Is it 2 or 3? Oh, I have noticed that 12, 18, and 24 are divisible by 2. Also by 3. All right? Now, we can just use the smaller one, which is 2. Yeah. 12 divided by 2 is 6. 18 divided by 2 is what? 9. And 24 divided by 2 is 12. Let's check 6, 9, and 12 once again. Are all of them divisible by any prime number? By 2. Are all of them divisible by 2? No. How about 6 and 12? Are 6 and 12 divisible by 2? Yes. How about if all of them will be divided by 3? Could it be? Yes or no? Yes. All of them can be divided by 3 without remainder. 6 divided by 3 is 2. 9 divided by 3 is 3. And 12 divided by 3 is 4. Let's check once again. 2, 3, and 4. Are all of them divisible by any prime number? No. How about 2 and 3? No. How about 3 and 4? No. How about 2 and 4? Aha. It's yes. 2 and 4 are divisible by 2. So 2 divided by 2 is 1. And since 3 is not divisible by 2, we just copy it. Write it down. And 4 divided by 2 is 2. Let's check once again. Are 1, 3, and 2 all of them divisible by any prime number? No. 1 and 3? No. 3 and 2? No. 1 and 2? No. So, in this case, we will stop dividing and we just multiply the numbers at the left side of L, okay, and the numbers at the bottom part 1, 3, and 2. So 2 times 2 times 3 times 2 times 3 times 2 is equal to 144. So the least common multiple or LCM of 24, 36, and 48 is 144. Let's go to example number 3. Let's find the least common multiple of 72 and 96 using division or the L method. Oh, it's easier. We only have two numbers at this time, 72 and 96. Write them down. Write the division symbol, the improvised division symbol. It's not the real division symbol, it's just the improvised one. That is only used in continuous division. And list down the prime numbers, okay, which you will probably use as divisors. And 72 and 96, okay, there are just two of them, so it's easier now. Okay, are they both divisible by 2? Yes. So 72 divided by 2 is 36, and 96 divided by 2 is 48. Now, 36 and 48 are divisible by 2? Yes. 18 and 24. Are 18 and 24 divisible by 2 again? Yes. It's 9 and 12. Again, we always start from the smallest prime number. And if the smallest prime number is not applicable as the divisor, go to the next. Is it 3? Is it 5? Is it 7? Is it 11? Again, take note that you can use any prime number as long as it is divisible into 2 or 3 or 4 numbers from the given whole numbers. At least 2. All right? So, 9 and 12. Are 9 and 12 divisible by 2? No, not all of them, since 9 is not divisible by 2. But 9 and 12 are divisible by what? 3. So, let's divide 9 and 12 by 3, and the answer is 3 and 4. How about 3 and 4? No, they are not divisible anymore, all of them, by any prime number. So, let's multiply the numbers using 2. Okay, 2 times 2 times 2 times 3 times 3 times 4. Notice that the numbers are at the side of the L and the numbers at the bottom part, 3 and 4. If you are going to multiply all of them, the answer is 288. And we can say that the least common multiple, or LCM, of 72 and 96 is 288. Now, let's go to the fourth example, which is the LCM of 5, 6, and 7 using division method. All right, check. Are all of them divisible by any prime number? 2, 3, 5, 7. Oh, so what are we going to do now? Just multiply all of them. 5 times 6 times 7 is 210. If you want some techniques, 6 times 5, 30. 30 times 7. 3 times 7 is 21. Just add 1 0 at the end of 21. It's 210. And the LCM of 5, 6, and 7 is 210. Again, if the given whole numbers are not divisible anymore by any prime number, just multiply them. And the product is the LCM of those whole numbers which are given. Let's go to the fifth and final example. Let's find the least common multiple, or LCM, of 9 and 10 using division or L method. 9 and 10. Are 9 and 10 divisible by any prime number? Yes or no? No. So, just multiply 9 and 10, and the answer is 90. The least common multiple, or LCM, of two consecutive whole numbers is always the product of the two numbers. Let's say 3 and 4. 3 times 4, 12. The LCM of 3 and 4 is 12. 5 and 6. 5 times 6, 30. The LCM of 5 and 6 is 30. 6 and 7. 6 times 7 is 42. The LCM of 6 and 7 is 42. Take note that 9 times 10 is 90, and the least common multiple of 9 and 10, or the LCM of 9 and 10, is 90. To sum up our lesson, take note that the LCM of the given whole numbers is the smallest whole number that is divisible by all the given whole numbers. LCM is used in adding and subtracting dissimilar fractions. If the greater whole number is divisible by the other whole number, the LCM of the two given whole numbers is the greater whole number. The LCM of the two given whole numbers is greater than or equal to the bigger whole number. The least common multiple, or LCM, of two consecutive whole numbers is the product of the two whole numbers. Prime numbers are used in finding the LCM of 2 to 4 numbers using division or L method. Okay, do not forget to answer the following practice exercises. Thank you for watching this video, and I'll see you next time.